Now we'll look at this powerful higher order function called map. So map, right, is a higher order function, means map takes another function as an argument. So it takes a function and it takes another list and applies this function to every member of the list and creates a new list. That is, I have a map, right, and then a function. I will apply this function f to each member of the list. That is, apply f to n1, f to n2, apply f to n3. Or you apply the function cook to each of them, right, and then you create, right, you apply this method to each member of the list, and you create a new list. Map is very powerful, okay? So why do we need a map, right? You really have to understand the map. So let's look at a few examples, say why we need a map. So here's a double function. Double, right? It takes a list. I want to double each item in the list. That is, now I have to match a list. If it's empty list, I return an empty list. If it's not empty list, then okay, I'll split into head and tail. I'll double the head, and then recursively, I have to do the exact same thing to the tail, okay? Do the exact same thing to the tail. That's my double function. So if you apply double to 1, 2, 3, 4, you get 2, 4, 6, 8. Now let's look at another example. That will be a negate function. That is, if you give me a list, if the list is empty, return an empty list here. If the list is not empty, so I want to negate every single element in the list, I will again deconstruct it, head and tail. I will negate, right, the head. And now I still have the smaller version of the same problem, so I will, right, recursively call negate to the tail, right, to the tail. Now if you apply this negate function to 1, 2, 3, 4, yes, you get -1, -2, -3, -4, okay, -4. Now, let's look at, right, how these functions are same, how they are different. So definitely, the name of the function are different. This is double, this is negate, right? And then match, look at that. Match is exactly the same. Empty is exactly the same. If it's empty, I return an empty list. This part, right, this is the only different part, because now you do the negate, double, you do the double, and then whatever the name of the function, you're doing exact same thing to the tail. So you could have a lot of functions in similar way. Double, negate, +1, right? Square root, square. So we want to generalize. Look at these two functions, and then I say, okay, based on this double and negate, only thing different is how I am processing the head of the list. Everything else is the same, so I should generalize that. With that, we have this thing called map. Map, right? Map is a recursive function. It takes a function f and a list. So this is, compared with the double and negate, this f is an extra thing. Now this is same, this is same. Look at this part. Remember? Based on each function, I process the head differently. That's what I'm doing there. So if you give me an f, I will apply that to the head of the list. And then after that, I will process the tail, the same way, recursively. With this, we have map, right? Now this map is, again, I said, it's very powerful. It takes a function and applies to a list and generates a new list, right? And the function f could be all different kinds of things. For this example, the f could be double, then it doubles every item on the list. F could be negate, it could, negate every single item in the list. So this is an implementation, right? Definitely during the exams, we will give you the implementation, so you don't have to remember this, but you should know what this map doing, right? It is a recursive function. If you give me an f, I will apply that f to the head of the list, and then I will apply this f to the tail. That means every single item in the list, and at the end, I will put them together. So if you still remember from Ruby, this is a collect function in Ruby, or map function in Ruby. So now, because we look, every time we look at the function, we check its type. So now let's look at the type, right? Map is a high order function, so it takes function f, right? It takes a function f, and it takes another list, and then, right, it generates a list, right? It generates a list. So the idea is it takes a function that is my f, and then it takes a list. And in the list, there's really no restriction whatsoever. Any kind of list, that will be a tick A list. That is my LST, right? LST. So then what does it return? If you give me a tick A list, right here, I am applying f to the head of the list. That is tick A. That means the function f takes a tick A. That is single item from the tick A list. What does it generate? I don't know. It depends on the function. You could generate anything, right? With that, I say, oh, okay, if you can generate anything, that will be B. That means this whole thing right here, it generates tick B, right? Tick B here. So if this one thing is tick B, then this entire thing is going to be tick B list, because you can insert tick B only into a tick B list. With that, you know this type of this return type of this map is going to be tick B list. That is, I will take a function. That function takes any type, return any different type. So it'll take tick A, return tick B, and then I will take another list of tick A list, and then I will apply this function. I just convert every single A to B, applying this function here. Eventually, I return a tick B list, okay? Tick B list. That is a return type of, it's the type of this map function. Map function is given inside this list module. So if you go to list map, you will see that exact same thing. That is, takes a function, takes a tick A list, and then applies that function to every single member of the list and generates a tick B list. Okay? That's our map. Now let's look at some examples where to learn how we use this map. So here's this very simple example. That is, I have a double function, right? It takes a single x and then multiply by 2. It doubles it. Now I have a list of 1, 2, 3, 4, 5. Now I will apply this double to every member of the list. That is map double list. Then you get 2, 4, 6, 8, 10, right? Each item is doubled. Okay, that's how you use map. Now let's look at some examples. The very first example, subtract 1 from every item in an int list. Definitely is an easy example. That is, I have a list of 1, 2, 3, 4, and I have an anonymous function. If you give me an x, I return x minus 1. That's the subtract 1 part. I will send this anonymous function to map as a f. Remember, as a function. Then map will apply this anonymous function to every single member of the T and return a list. Or you can bind this anonymous function to a variable that's here, right? I create a sub1, the function. It takes x, returns x minus 1. I will apply, right? Use map to apply this sub1 to every member of the T. You get 0, 1, 2, 3. That is minus 1 from each element here, right? In this list. So that is our example 1. Let's do another one, right? We have like 5, 6 examples. So let's go through all of them. So exact same, right? I'm just enforcing the same concept right here again. Negate every single item from the list. Now you know how you're going to do that, right? I create a negate function. That is, if you give me an x, I multiply by minus 1. Now I'm going to send this negate to map, right? So map will apply this to every single member of the T. You get the new list of -1, -2, -3, -4. Cool? This is a little bit more. That is, I have a list of functions applied to an integer list. That is, I have an integer list of 1 to 3, and I have 3 functions: negate, sub1, double. These are the functions we saw earlier. Each of them, they have a same type. They all take an integer, return an integer. So I can put those 3 functions into a list. That is, my function list is going to be neg1, neg sub double, right? So the type of this list now is int to int list, right? Int arrow int list. It means each item in this list is a function that takes an integer, returns an integer. Now, I will, right? I will take, look at that. I will take one item from this list. This is definitely a little bit more. Let's maybe we have to do it a little slow. So this is, here, this is a function list. So that function list is right here. So it takes one item. Remember, it takes one item from this list, and then it will, right, apply this. This is the original f. If you take one item from this f, that's going to be x, let's say. So now apply f to x. That is, this x, or I will use a different variable, let's say a. So this a will go in, it will replace this x. Look at that. Because you're applying this red anonymous function to one item from that function list. That is, if we do this real example, that will be, this is like a neg. Neg goes in, it will be, right? It will replace every single x inside the body of this anonymous function. So this is going to be neg. See what happens? Now the map, the inside map, it's a map inside map, right? The inside map will take this neg and apply to a list. It will create a, right, negative list. And then next time, the outside map right here, well, where's my thing? Here. This map will take the next function that's not neg anymore, that's a sub1, and then the sub1 will go in, and this map will apply sub1 to every single list. With that, you have, look at that. This is the result. That is, you take sub1, a neg from this list, apply to each item from the list, you get all the negative numbers. And then this map takes another item from the list, that will be sub1, and send the sub1 as an x to this anonymous function, and then map will apply this anonymous function, the function now, to every member of the list. That is -1 from 1 to 3. That's this. Now the very last item will be double. I'll take the double, send it to this x. Then map will apply that x to the list. That is, take this list. I will write double each item. That's a list of lists, right? But look at that. Just this one line, right? It takes a list and then apply each function to the list, generate a new list, and eventually put them together as a list of lists. So this is definitely very short and very powerful function, okay? Question is, right, is saying, what if I apply each of them to the one item from the list, first one, and again come back, apply all of them to the two in that order, right? Yes, is that the question? Then you have to change the order of these two maps. The map here is doing, take a function, apply to all the lists, right? Then you reorder these two lists, right, differently. Then you can take, right, one item and apply all the functions to that one item, and then take another item, apply every function from here to that second item, put that as a list. Yeah, you can do that. Question? I'll reiterate the question. The question is, what is the type of this entire function? So let's start with this. This thing is int to int list. Right? So this is tick A list. Remember this, this item we said it should be tick A list, so this is tick A. If it's a tick A, then this function inside here, its type is, remember it's tick A to tick B. In this case, it'll take int to int. That's my tick A, and then it will generate, right? It'll generate a B. In this case, B is going to be an int list. If it's an int list, remember, then this whole thing will generate tick B list. If tick B is int list, then the whole return type is int list list, right? So this is a type. So if I copy that into the top level, that will be this map function. It takes a function that type is int to int to int, and takes two integers and returns an int list, and then takes another list that's an int list, and then a return int list list. I know this is ugly and confusing. Please try that after the class, okay? But I can ask that in the quiz tomorrow. Okay, let's continue. I know map is so fun. Everybody likes it. Example 4. So now we go to the level of like interview questions, right? So that is, if I give you a list, give me the permutation. If you give me 1, 2, 3, yeah, permute the list, right? Permutation. With that, I have two helper functions. One of them is called remove. If you give me a list, if you give me an item, I will remove this item from the list. And then I have insert to permute. That is, you take one item, right, and then permute everything after that and insert that one item to each list. That is, look at this case. If you have one, go back. This is they're really doing. If I have 1 and then a list of 2 and 3, permute this, that is 2, 3, and 3, 2, and insert 1 into each of them. So this will become 1, 2, 3. This will become 1, 3, 2. Now you get the idea. So if you give me a long list, I'll just take 1, permute a tail. From that, you take 1, permute a tail. If I keep doing that, then I get this permutation. Again, I mean, walk through this, each of them. We don't have that much time in this class today, but after this class, you should definitely look at how this thing works. And then compare it with your Java code, the permutation you do with the recursion, or usually it's recursive, right? See the differences, right? A flatten is taking a list of lists and it makes a list. That's flatten. Otherwise, this is definitely a difficult function. I know, if you're confused, please, after the class, look at it, right? But don't be scared. Eventually, you'll be doing more complicated things than this. Yeah, question?
Is list.map the same as map?
Yes, I'm sorry. I should have changed it. So this list.map. So because in this example, I'm using the filter, map, flatten. They all defined in the list module. So I put list. But otherwise, if you don't have a list here, you have to have a definition of map before this code. Okay? Otherwise, this is a permutation. One more. This is a quiz, right? We don't have to do it now. Just leave it inside this deck of slides. When you know enough of map and fold, please come back and look at it. That is a power set. So definitely you don't see these kind of questions in the exam or quiz, maybe in a project. So this is saying, if you give me a 1, 2, 3, generate all the possible subsets. 1, 1, 2, 1, 2, 3, 1, 3, 2. They're all, right? A subset of 1, 2, 3. Power set is all the subsets, right? This is the power set function. It used something called fold right. We didn't see it yet. That's why I leave it as is. Please look at it when you're comfortable enough with map and the fold. That we will cover next. One more question? Okay. So let's just get the summary. We looked at the higher order function map, right? So map takes another function, applies it to each member of the list, returns a new list. Implementation of map is given in the list module. You just have to say list.map, and you don't have to implement it. But otherwise, it's the same implementation we showed you is given in that module. Map is very, very powerful.